Now this is section 2.1, which is the first method in solving first order differential equation. Before I start section 2.1, I will give you an overall idea of the chapter. This chapter is about solution of first order differential equation. We'll be doing 5 methods to solve the first order ordinary differential equation. The first method is separable differential equation. Second method will be homogeneous differential equation, and the third, which actually this method, second method, depends a little bit on the first method. Method 3 is exact differential equation, which really is not related to the previous methods. Method 4 is integrating factor, which totally depends on method 3. And the last method, which is method 5, is the linear first order differential equation. So we'll end up with 5 methods, and by the end of the chapter, if a first order differential equation is given to you, you should be able to decide which method to use. One more thing we'll be doing in this chapter is an application, which is in section 3. Actually, it's an application for all methods. A small application which we are going to do end of the chapter. Now we are back to section 2.1, which is the first method in solving first order ordinary differential equation. This is separable equations, separable differential equation. We are going to see what is separable differential equation and how do we solve it. A separable differential equation is of this form. When y prime is a function of x times function of y. So we have a product between function of x and function of y. Because when we have a product, we can separate the variables. We can bring gy here as 1 over gy with dy, and keep the hx with dx, bring dx that side. And then we can integrate both sides and end up with a solution. Now, let us consider different examples of, quick examples of separable differential equations. Now, this is, for example, a separable differential equation, a very simple one. The reason we call it separable, because we can separate 1 over y and x dx. And then we can integrate both sides, which is ln y equal to x squared divided by 2 plus c. Now, the reason we need to separate, because we are not allowed, by the way, to do this. Some students, if they have y prime equal, they will think that we can integrate both sides, which is very bad. You cannot integrate this side because you don't have a d. For integration, you need a dx or a dy. And even if you bring a dx this side, if you leave a dy here and bring a dx this side, you cannot integrate also, because you cannot integrate y, which is an unknown function of x, dx, because y can be sine x, it can be anything else. So you cannot integrate y dx. And that's why we need to separate. We separate dy with the function of y and dx with the function of x, then only we'll be able, or we are allowed to integrate both sides, just like normal integration. Another example of separable differential equation is this. For example, this is a very simple one, because you can separate. You see here, you have a product, you have function of y times function of x, but you don't have to think of the product. You can see the separation sometimes without thinking of the product. Another example is this. This is also separable. You see, when the right hand side is a function of y only or a function of x only, then it must be separable, because there is nothing really to separate. So it must be separable. You can bring this side, 1 over y dy, leave this side dx, and integrate. Another separable differential equation example, this is another example, because you can write ey ex, this is dy dx, and you can bring the ey this side as minus y here, and leave the ex dx. These are very quick examples of separable differential equations. We are going to start now some exercises. Another exercise, okay, is this, which is number 2 in section 2.1. You see, now this is a separable differential equation, and we don't have to think here of a product of function of x and function of y. This can be seen that it is separable without thinking of a product of function of x and function of y, because you can see that you can keep the y here and bring the 2x plus e2x with the dx to the other side, which means separation can be seen. Okay, so really in separable differential equation is when you have y prime equal a function of x times function of y, but we don't have to think of this. Sometimes we can just see the separation. So you can separate like this and then integrate. So integration of this will be that, integration of this will be 1 over 2 e2x plus c. Another thing, this is now, which is a question, and it is common question which is asked by many students, which they always ask, why do we put c here and not here? Okay, actually, if you put c here and c to the other side, this c will come on this side and you're going to have c1 plus c2, which is another c. So there is no need to put a c on both sides. It's enough to put a c on one side. So here are some exercises of section 2.1. For example, exercise 6. This is a separable differential equation. It's already in separated form because this is function of x dx and function of y dy. So simply you just have to integrate. You don't have to separate anything. Integration of hyperbolic cosine as 1 over 6 hyperbolic sine 6x plus a 3 over 2, because this is 2 hyperbolic cosine 2x equal 3 over 2 hyperbolic also cosine 2y plus c. And number 8, this is actually, we have a product here because we have 1 over secant y tan y. So we have a product of a function of x and function of y. But like we said before, separation can be seen without thinking of the product, because you can write secant y tan y on this side with dy, and you can keep the cosine square x this side, bring the dx, and then you can integrate. Integration of secant tan is secant. Integration of this, which is 1 over cosine square, that is secant square, so integration is 10. Before I continue with more exercises, I must say one thing. You see, we have always said that we need to have a product of a function of x times function of y in order to separate. Because you see, if you have a function of x, a plus or minus function of y, for example 2y, let us say, okay, now then this is a plus 2y or a plus y, anyway, a function of x plus function of y, then it is not possible to separate. Even if you bring the 2y here, you are not going to have 2y dy. It will be minus actually 2y plus dy. That is not possible. That you cannot integrate this way. So you need a product in order to separate. Another exercise is exercise 12. You see here you have dy dx, a function of x only. When a differential equation of first order is equal to a function of x only or a function of y only, it must be separable because there is nothing to separate really. Now, so here you can write dy equal x minus 2 divide x squared plus 2x plus 1 dx, and then integrate both sides. Left side is y. Right side has to be done by partial fraction, which means you have to factorize the denominator. But after factorizing denominator, because you have a repeated factor, you can actually write, you can add 1 and subtract 1 in numerator, and it can be done really without partial fractions also, and with partial fractions if you prefer. But this can be written as, you can separate numerator, you can write x plus 1 square minus 3 divide x plus 1 square dx. This 1 will go with this, okay? So you have y equal integration of 1 over x plus 1, which is ln x plus 1, then minus 3, you can take this up as x to the power minus 2 and integrate, and it will become x plus 1 to the power minus 2 plus 1, which is minus 1, divide minus 1, so this will become plus c. Another exercise is number 10, okay? Again here, the separation is very obvious. You can bring the dy here with e to y and bring the x function this side, so you can say x ln x squared plus 1 divide by x squared plus 1 dx and e to y dy. Okay, now and then integrate both sides. Integration of this, if you think about it, actually this is u, this is like u, and this one is u prime. So actually you can rewrite this, this way. If you separate, this is ln x squared plus 1, okay, times it is x, you can look at it this way, dx, and integration of this, it's easy, e to y, so plus c. This is now, like we said before, this is u, this is u prime, but you need what only? You need a 2, so you have to divide by 2. So the integration will be 1 divided 2 ln x squared plus 1 to the power 2 divided by 2 equal to 1 over 2 e to y plus c. This can be written as, if you multiply both sides by 4, left side will become ln x squared plus 1 square, because this will cancel if you multiply by 4. Other side will be 2 e to y, because this will cancel with 4, and then 4c here, which can be written as another c. The last exercise, which is very simple, there is a common factor here, which is ex. It will cancel with this, and you are going to end up with dx dy equal to y divide 1 plus y squared. This is again now, this is a function of y only, so it must be separable, and you can write dx equal y 1 plus y squared dy. Integrate both sides, so this is x equal 1 divided 2 ln 1 plus y squared plus